about the second law of thermodynamics. Second law of thermodynamics. Second law of thermodynamics, and its most important term is entropy. So before that, whatever we have learned up till now on that knowledge, so I am going to have one question to you. I should go for presenting that question to you. Okay. Okay. So here is one question to you, that refrigerator is kept in home and it is opened. It is started now. Assume that it is started. Electric work is also given to us. Now, can you tell me, or can this refrigerator will cool the room in which this refrigerator is placed? So that answer I want from your side. So I request everybody to put your answer in this your message box. You think on that and tell me.
Hello, sir.
The situation is, yes, I have significant question. Hello?
Hello.
Huh?
Can I say about this
Can I?
question? Talk about this question.
Huh?
Sir.
You can say, no problem, no problem.
Sir, the second law can't be broken because if we open the refrigerator to cool the room, because outside temperature is hot, so the temperature will flow from high temperature to low temperature zone, and the refrigerator will get heated, so it can't cool the room.
Okay, very nice. Okay, your explanation is over. Okay, let others should speak, and then afterwards I will answer your question. You are okay, but I will not say now whether your answer is right or wrong. But I will tell afterwards, because if I will give this remark, then everybody will say that this is your answer is correct. But you are on right track. So okay. So Jaydev Nanavre, no sir, means his game. Yeah, sir, Yusuf is also there, no sir. So this refrigerator is not cooling the room. It will. So let now Sachin Sagar, I am agree to Abhinav. Okay, no, the room will be more warm. Okay, Azam Sheikh. Okay, very nice. Okay, so now I have to proceed to give explanation. Correct. So all my friends, Jaydev, Yasser, Azam, Sachin Shirsagar, whatever they are given their answers, there it is exactly correct. And whatever given by explanation given by I think Abhinav is also correct. So it is what, as this room is this refrigerator doors are opened. Okay, then all heat it will be there. So surrounding is at higher temperature, and the refrigerator is at lower temperature, and definitely in that case, before is first of all what will happen, that heat will flow from high temperature to low temperature. Then first of all, whatever the room temperature, it will become equilibrium, and but afterwards we are running the compressor, and from that compressor some work we are providing to that particular compressor, and we know that that work is also get converted into heat, and whatever the continuous work we are supplying to that particular compressor, that afterwards that work is continuously get converted into heat, and afterwards after equilibrium happened achieved, then that room will become warmer and warmer. So instead of cooling that particular, the refrigerator will not cool the room, but definitely that room is going to be become warmer and warmer. So this is going to be the such kind of questions at the time of interview also they are going to ask for you. Okay, then now we'll proceed for yesterday's whatever some quiz we have remained. So that quiz will go for now today. Okay. Uh, okay. So yesterday, I think, okay. So first quiz we have completed. Second, okay. Third, we have completed. Then fourth, gas is compressed. I think that also we have completed. Then which of the following states of thermodynamic laws relations is directly involved? So that also we completed. Work done in free expansion, repeated. Always this also we have completed. Then last quiz, the values of heat transfer and work transfer for process of thermodynamic cycle are given below. So, and we expected the efficiency, okay, thermal efficiency and the work ratio. That also we have completed. Now today's first quiz. Okay. Now if a heat engine gives an output of 3 kilowatt when the input is 10,000 joule per second, then the thermal efficiency of engine will be. I think everybody's screen the question is appearing. So I expect now it is a heat engine gives an output of 3 kilowatt when the input is 10,000 joule per second. Then the thermal efficiency of the engine will be. Very simple question asked in IAS 1995. So you can give the answer in your message box. The answer is C. Many students. Okay, display audit. Okay, many are giving answer C. Okay, so very simple question. So heat engine gives an output of 3 kilowatt when the input is 10,000 joule per second. So that either 10,000 joule per second is converted into kilowatt. Okay, joule it is watt and means it is a 10 kilowatt, and definitely input is 10 kilowatt and output 3 divided by 10. Answer will be so correct answer. Maximum are giving answer C. They wrong. So it is a so answer is I think output is 3 kilowatt and input is 10 kilowatt. 3 divided by 10 it will become 30%. Answer will be B. So okay, now many students are giving answer B. Okay, Harshvardhan, Shraddha. Okay, Sachin Shirsagar. Now Sachin Shirsagar changed his answer. Yes, sir. It's output divided by input, but to give calculation. Yes, sir. Okay, and so I will give that answer is okay. 30% answer. So answer is B. 30%. So in okay. So input is 10 kilowatt and output is 3. Output divided by input is efficiency. Very simple. So thermal efficiency W divided by Q. Okay. Next question is ready on your screen. 170 kilojoule of heat is supplied to a system at constant volume. Then the system rejects 180 kilojoule of heat at a constant pressure and 40 kilojoule of work is done on it. The system is finally brought to its original state by adiabatic process. If the initial value of internal energy is 100 kilojoule, then which one of the following statement is correct? Okay. So I expect answers from you, message box. So 170 kilojoule of heat is supplied to a system at constant volume. So system is having constant volume and 170 at that time 170 kilojoule of heat is supplied. Okay. And initially when that system is there at this definitely initial internal energy was 100 kilojoule. Then the in which of the following? So if the initial value of internal energy is 100 kilojoule, then which one of the following statement is correct? This is the first answer, that is the highest value of internal energy occurs at the end of constant volume process. The highest value of internal energy occurs at the end of constant pressure process. And C, the highest value of internal energy occurs at after adiabatic expansion. And internal energy is equal at all points. Okay, so Nana Sahib Shinde, Abhinav Gaikwad, Sachin Dipjyoti Sathe, okay, all are giving answers A. So majority is there, I think, up till now. Up till now, we got that majority is always carrying right answers. Okay, so Deep Jyoti, Sachin, Shiv Sagar, Nana Sahib, Abhinav, they are giving option A. Others can think and they can give the answer. So I have given that internal energy is a function of temperature. And if we add the heat at constant volume, definitely here temperature is going to be increased. Heat is going to be added, therefore definitely temperature is going to be increased. And in definitely internal energy is going to be more. They are correct. The highest value of internal energy occurs at the end of constant volume process. Correct. Because at constant volume only we are supplying that 170 kilojoule of heat, and therefore as this heat is going to be added, definitely yes, internal energy, this energy plus internal energy, function of temperature. There is adding temperature, therefore I'm getting temperature is because Q is VDT. Then yes, there, and after process happen work, and as work is obtained, definitely here heat supply remains same, but in that case internal energy is also going to be decreased because some part of it gets converted to work. And after expansion, the internal energy is go on increasing. So answer will be definitely A. Correct. The answer is A. So at the end of constant volume process, internal energy will be highest, and afterwards goes on decreasing in expansion. Means afterwards it will energy will not. So it will be more end of constant volume process. Okay. Now next question. Okay. A gas contained in a cylinder is compressed, the work required for compression being 5,000 kilojoule during the process. Heat interaction of kilojoule causes the something to be heated. The change of the gas the process is. So question is on your screen. So I expect that more correct answer should. The answer, gas is contained in a cylinder, compressed work is there. So it is asked in GATE. Okay, GATE examination 2004. So B, Amul Mali is giving answer B. So what is that? B is there. So B is answer. So gas is cylinder compressed work is dW is equal to 5000 kilojoule. Interaction, during heat interaction cause surrounding to be heated. Supplied heat is 2000, and definitely in that case dq is equal to 2000, and compression we have to give the work. My work is minus 5000, because we have to supply the work minus 5000, and therefore 2000 we are heat interaction to the surrounding. Also heat is also rejected, therefore it is also minus 2000 is equal to delta u minus 5000, and if that 500 will come to this side, it will become plus minus 2000 plus 5000. Answer may be C, that is plus 3000. C, so how many I don't know. So C is there, Dhanasri Sonone I think, okay, Yogesh Samudhi Deshpande, okay, then Arno Gaikwad. Okay, so remember sign conventions also we have to remember here. Gas contained in cylinder is compressed, means work we have to supply. This will be minus 5000. The heat action 2000 kilojoule, the surrounding to be heated. Means we have to supply heat to surrounding. It is also minus 2000, and entry delta U have to find out. So definitely it will be minus 2000 is equal to U plus W, and in that case it will be 3000 I think. The answer is C, correct, 3000 joule. How it is coming 3000? So okay, so what is the answer is there, that heat supplied is minus 2000 because it is supplied to surrounding, and delta U plus W is also supplied, therefore it is minus 5000. So these are the answers. Okay, another now when out is not animated, so definitely that. Now okay, here PDV work or one question. Dynamic work is the product of. Thermodynamic work is a product of. First, two intensive properties. B, two extensive properties. C, and an intensive property and change in extensive property. D, an extensive property and change in intensive property. Now thermodynamics P is equal to W is equal to, sorry, thermodynamic work is equal to P into dV. Okay, so P into dV means what is P and what is dV. So that we have to go for. Okay, answer is, anybody is commenting answer? Okay, so thermodynamic work is product of P into dV. So P is intensive property, dV is extensive property. So it is going to be product of one intensive property and change in extensive property. So answer will be C. Okay, nobody has commented. So answer is going to be C. Okay, next question. In steady state, steady flow process, in steady state, steady flow process, taking place in a device with a single inlet and single outlet, the work done per unit mass flow rate is given by W is equal to minus VdP, where V is specific volume and P is pressure. Expression for W given above. What is V? W is equal to minus VdP. So this expression is going to be valid for which process? Is valid, A is valid only if the process is both reversible and adiabatic. Is valid process is as valid for process. P is, it is incorrect. It must be W is equal to PdV. Okay, so what is your logic? So is okay. So reversible process there is valid only for reversible process. Other processes where cyclic processes we are considering, okay. Other processes are there. We are generally considering work as a PDV, but only for reverse process. Okay, and if the steady state, reversible process, the work can consider as a PDP. So this is going to be valid only for the reversible. Okay, next question will go for a gas. Okay, here a, it is not as a gas expands in friction cylinder arrangement. The expansion process is and is restricted by an pressure of 100 kilo. During the expansion process, the pressure of the system gas remains at 300 kilo. The change of volume of the gas is 0.01 meter cube. The maximum amount of work that could be utilized from the above process is. So gas is expands in frictionless piston cylinder arrangement. Work is doing now quantitative. The expansion process is very slow and is resisted. Okay. Answers. The gas expands So answer, anybody is giving answer?
C, sir, C.
C. Okay, 2 kilojoule. Who is giving now? Anybody is okay. The answer is C. Okay. How it is coming C? So volume change in volume is there, that is dV, and pressure change, that is a PdV. Generally, we calculate the work only reversible adiabatic process. Reversible process work is here minus VdP. Other processes work is going to be PdV. But here ambient pressure is given 100 kilopascal and our gauge pressure is given as 300 kilopascal. So that pressure we have to convert into our absolute pressure. So absolute pressure is equal to here that atmospheric pressure is 100 kilopascal and gauge pressure is 300. So gauge pressure minus atmospheric pressure is equal to your absolute pressure, and that absolute pressure will be 200 kilopascal, that is P, and dV change is 0.01 meter cube. The answer is equal to C, that is 2 kilojoule. Okay. So here PdV, gauge pressure is there, it is going to be 300 minus 200 is equal to into that volume 0.1. So that is directly they have converted. If it is as it is a work is there in kilopascal, so directly 0.1, that answer is we are getting in terms of kilojoule. Okay, for next, for reversible adiabatic compression in a steady flow process, the work transfer per unit mass is, the reversible adiabatic compression in a steady flow process, the work transfer per unit mass is. Anybody? So reversible adiabatic compression, reversible process, and it is a compression. Therefore, we have gone for VdP, is the work minus VdP. Okay, but here pressure is going to be compression, so it is going to be steady flow process. The work transfer per unit mass is VdP. So well, we know that reversible processes, the work is always equal to VdP, and other cases the work is only PdV. So this will be the answer, as because minus VdP, but as compression is there, that work we have to consider as a supply. Therefore, it is a minus of that sign. Therefore, VdP, the work transfer per unit mass will be VdP. Okay, the answer is here VdP because it is reversible process. Remember that in the reversible processes, work transfer is equal to VdP. And other processes, the work transfer is PdV. Okay, now I expect everybody should involve in this because it is familiar with everybody. Match list 1 with list 2 and select the correct answer. Okay. So match list 1 with list 2 and select the correct answer using the codes given below. So list 1 is parameter they have given, and list 2 they have given the properties. Okay. So list 1 they have given the properties parameters. A is volume, B is density, C is pressure, and D is here work. So list 2 path function, intensive property, extensive property, and point function. Now we have to go for the pairing, volume, whether it is path function, intensive property, extensive property. Then you can write roughly so that way next slide I am giving that your answer options. So options are, so you write down first volume, density, pressure work here on one side, and their pressure path function 1, 2, 3 ABCD here, and one path function intensive property, extensive property, and point function. Now volume is what? Volume is, so their option is what? 3241, B 3214, C 2341, D 2314. Okay, so the next is on A2. Volume is extensive property. So remember that volume is extensive property. Therefore, answer should be start from 3. So 3, where is 3 is there? So 3 is there only in case A and B. So answer should be either A or B. Okay. Okay. Therefore, next is there that density. What is density? Density is a intensive property. So B will be 2. So 3 A3 B2. Where it is there? A3 B2. So answer will be definitely A3 B2 4 C. Pressure is a, work is a path function. So D is 1 and C is going to be, pressure is a property, 0.4. So pressure is a property, means it is a point function, C4. Okay, so C4 is there, and so answer is A. A is correct. So Sunil Vaishnavi, okay, Sachin Shirsagar is also correct. Bharat is correct. Nana Sahib Shinde, Samruddhi is correct. A is correct. Dhanasri Sonone is wrong, I think. So Deep Jyoti Sate, before that, okay, I was not knowing how to see the message box, but after now I am clear. So Sate A3 B2 C4 D1, correct. So maximum students got this answer. Okay, now yesterday that question we covered little revision. Which one of the following sets of thermodynamic laws relation is directly involved in determining the final properties during adiabatic mixing process? So this is a D answer. It is the first law of thermodynamics and perfect cast relationship. Okay, now next question. For a closed system, the difference between the heat added to the system and work done by the system is equal to change in. For a closed system, so closed system, we know that law. So it's D. So the, okay. So dq is equal to du plus dw. For a closed system, difference between heat added. So dq minus dw is equal to change in internal energy. Answer should be D. Anybody is giving the answer? Okay, Samruddhi giving the answer. Shraddha Gajal was D. Okay, Bharat. Okay, everybody is giving the answer. So we should not wait for this question. So Sneha Miraskar also D. Okay, everybody is giving the answer. No problem. For a closed non-aside cylinder D. Okay. The change in Abhinav Gaikwad D. Okay. Okay. Now next. Now this also that is asked for IES. Okay. Now the following four figures. Okay. This is not that figure not with me. Therefore now we'll keep this. Okay. Which of the following is correct? The cyclic integral of Q minus W for a process is. So cyclic integral of, so for a cycle Q and W, it cyclic integral of dq is equal to dw. Therefore, the difference is how much? So that answers now. Everybody, I request go for it. Please your answer put in your message box. Very simple. Okay. So H Gadekar C, Nana Sachs and C 0 0. Okay. So this answer is 0, but you will get full marks. Okay. Vaishnavi Vaishali More C, C Bharat Burungale C. Okay. Sunil Sadul C. Okay, okay, no problem. So cyclic integral of dq is equal to cyclic integral of dw. Therefore, difference is definitely 0. So because there is no difference in between this q and w, both are same in the cyclic process. So therefore, answer is going to be 0. So answer is also giving answer C. Amol Mahali C. Okay. So shall we go for next? Okay. Now that is think. Okay. Yesterday, I think we covered this. I think the closed system undergoes the process 1 to 2, for which the value of Q1, 2, and W1, 2 are 20. Yesterday, we covered, I think, minus 40 something. So we should not go for this. Okay. So this is temperature scale one formula we have to analyze. I have to tell. Now here, a gas is compressed in a cylinder by a movable piston. Okay. To A gas is compressed in a cylinder by a movable piston to a volume one half of its original volume. During the process, 300 kilojoule heat left the gas and internal energy remains same. What is the work done by the gas? The gas is compressed in a cylinder by a movable piston to a volume one half of its original volume. During the process, 300 kilojoule heat left the gas and internal energy remains same. So delta U is equal to 0. What is work? Yesterday only I think work covered. It is I think D 300 kilonewton meter. So delta Q is equal to 0. Sorry, delta U is equal to 0. Therefore, dq is equal to dw only. It is also steady flow. Okay, here in a steady flow adiabatic turbine, the changes in internal energy, enthalpy, kinetic energy, and potential energy of the working fluid from inlet to exit are minus 100 kilojoule per kg. Okay, minus 140 kilojoule per kg, minus 10 kilojoule per kg, and 0 kilojoule per kg respectively. Which one of the following gives the amount of work developed by the turbine? Okay, now tell me answer. So in a steady flow adiabatic turbine, adiabatic means what? Whatever the heat and energy is there, it is going to be whatever the heat is supplied to the turbine, it is only rejected to condenser. After it is not supplied to surrounding. That is adiabatic turbine. So there is no loss of energy only. So which one of the following gives the amount of work developed by the turbine? So tell me answer. this is answer is D. Abhinav Gaikwad D. Okay, Dhanasran D. Prajwal Musa D. Okay. So how we are calculating D? So kinetic energy and potential energy in work exit minus 100 kilojoule, minus 140 kilojoule, minus 10 kilojoule, and 0 kilojoule respectively. Which one of the this answer will be there? So what is the work developed by the turbine? So that steady flow energy equation we have to apply here, and from that we have to calculate the work done developed by the turbine, and this is equal to I think 150 kilojoule. Okay, so it is I think it is the answer is 150 kilojoule. So I think here it is this magic. So change in internal energy is not required here because it is not function of the here work. We are only calculating the functions of that enthalpies, and 140 here it is going to be Wx is equal to 0 is equal to W 0 plus W is equal to 140 minus 140 minus 10 plus 0, and then in that case W is coming as 150. So I'm here that changed the site here due to this changed file. This I did not getting. So 0 is equal to, we can say it as a 0 here plus W is equal to minus 140, or 0 is equal to minus W minus 140 minus 10. So it is 150 is coming. So okay, change in internal energy is dq is equal to du plus dw in that case, and du value is also okay. Okay, next gas contained. So I will explain this afterwards. Last question. The gas contained in a closed system consisting of piston cylinder arrangement is expanded. Work done by gas during the expansion is 50 kilojoule. Decrease in internal energy of the gas during expansion is 80 kilojoule. Heat transferred in the process is equal to, very simple, dq is equal to du plus dw. Okay, and in that case here heat transferred in the process is equal to dq is equal to du plus dw. So we have to give work done by the gas is there. Therefore 50 is plus dw is 150 kilojoule is plus, and the heat internal energy of the gas during the expansion is 80 kilojoule is equal to 50 decrease there. Therefore it is going to be minus 50, and the energy decreasing, therefore it is going to be minus 80. 50 minus 80, I think heat transfer during that process is equal to, anybody give an answer? So answer is there, q is equal to de plus w. Decrease in energy is minus 30 kilojoule, work is 50 kilojoule. Q is equal to e plus w, so minus 30 plus 50 is equal to 20 kilojoule. So answer is B. Nobody is giving answer B. So gas contained closed system, work is 50 kilojoule, decrease internally, therefore it is going to be E is there, it is going to be delta E is equal to 80 kilojoule. Okay, and in that case, sorry, here it is going to be, mistake is there. Numerical it is 50 kilojoule, and during decrease internal energy is 80 kilojoule. So heat transfer dq is equal to it is is equal to minus 30 degrees and so it is printing mistake. So it is not decrease in internal energy is 80 50 30 kilojoule, not 80. So it is not 30, it is 80, it is 30. In this case, the answer will be here uh, delta Q is equal to means 80 plus 50 or 80 decrease that minus 80 plus 50. So it is going to be minus 30. But if 30 kilojoule is internal, then it is equal to 20 kilojoule. So it is minus 30 is correct here in this case. But okay, yesterday I think this we have covered. Okay, last numerical of today. A system while undergoing a cycle ABCD, ABCDA has the values of heat and work transfer as given below. So AB 687, this is a heat transfer, and this side extreme right is work transfer for okay 474 BC. The power developed in kilowatt is nearly. So in AB process, here are the work transfer and here is the heat supply. The power developed in kilowatt is nearly. How much work we are developing? It is equal to how much work you are getting. So last extreme side, they have given 474 minus 180, and in that case, work transfer we can get. Work where developed is equal to in kilojoule per minute. That we are getting. So this is a heat transfer here. Central kilojoule per minute is a heat transfer. Right side here we are having work transfer. So 474, and therefore we can say that 474 plus minus 180, 474 minus 180 will be the work in kilojoule per minute. Okay, work done in kilojoule per minute, and that is equal to I think kilojoule per minute, but we want that answer in kilowatt, therefore it should be kilojoule per second. It should be divided by 60. The answer is 4.8 or 4.9. So Jaydev Nanore is 4.9 he is getting, Nana Sachin is getting 4.8. Okay, so I think the answer is 4. Okay, we'll see. So it is very simple. So it is I think 474 minus 180, and is coming as I think 174 300. So 294 kilojoule per minute is coming. It should be divided by 60. Definitely answer will be A, that is 4.9. Okay. Now last, okay, still we are having 5 to 6 minutes. 5 minutes. So last question now. Okay. A tank containing air. A tank containing air is stirred by a paddle wheel. The work input to the paddle wheel is 9,000 kilojoule, and heat transport to surrounding from the tank is 3,000 kilojoule. The external work done by the system is, external work done by the system is, so we have to supply the work from system, therefore W we have to calculate. So a tank is stirred by the paddle wheel. The work input to the paddle wheel is 9,000, so W is 9,000, and heat transport to the surrounding from the tank is 3,000 kilojoule. The external work done. So definitely work input is 9,000 and the heat transport to surrounding is 3,000. The external work done by the system is 6,000 kilojoules. So how much we are getting? External is equal to change in internal energy, and this is equal to 6000 kilojoule per kilojoule is the answer. So anybody? The answer is C, 6000, correct. Sneha is correct. So 6000 kilojoule is the answer. Difference in between them is the external work supplied from the surrounding side. Okay. So today with this, now today we'll wind up our lecture. Okay, little bit now presentation, in my presentation some problem was there because we are getting fluctuated. So due to that little bit problem happened. But okay, let now next time we'll some 3 or 4 questions are remain that we'll take, and we'll focus on entropy and calculation of entropy during how to calculate the entropy in different thermodynamic processes. Okay, so I think Kashif sir has given separate link. Therefore, you need to go for that lecture by quitting this meet, and you have to join another meet. Okay, thank you. So we'll switch. We'll conclude today. Abhinav, Abhinav,
Yes, sir. Yes, sir.
stop recording now. You have to
Uh,
quit, I think, because Kashif sir has